Welcome back to the training. We'll now start into block 2, or comparing our roads and deforestation. Now that you've familiarized yourself with the study area, you'll take your analysis a step farther. First, you'll add a layer showing the extent of deforestation. Then, you'll quantify the percentage of land that is deforested within a certain distance from the roads. By finding the relationship between the existing roads and deforestation, you'll later be able to estimate the deforestation prevented by the proposed roads prohibition. Now, if you look on the ArcGIS screen in the table of contents, now this may look a little different from the previous training block. So what I've done is I've reorganized my table of contents. I now have cities on top to display on top of our official roads layer. In addition, I've created a separate layer outlining just the boundary of Redania. And I created that very similarly to how we created the official roads by creating a separate layer based off of selected features. If you have not done that yet, pause the video now and complete that step. Next, we'll take a look into exploring the deforestation. Now, although you looked at deforestation with respect to the colorized terrain in the previous session, you'll now begin to take a more thorough exploration, in order to understand the existing deforestation patterns in Redania. You'll start by adding a layer that shows deforestation in the state. Now, if necessary, open your Amazon deforestation map document in ArcMap. Then, in the Add Data window, we'll go ahead and add Redania deforested area by highlighting it and then selecting Add. Once it adds to the table of contents, let's drag this below our official roads and Redania roads layer. As you can see, this allows us to have the official roads display on top of that deforested area. Now, in the table of contents, let's click on the symbol for the deforested area layer. In the symbols selector, change the symbol's fill color to lime dust. Change the outline color to no color. Then click OK. This layer has only one feature. This is part of a multi-part feature, a feature composed of many non-contiguous elements. Deforestation typically occurs in small parcels, not large, unbroken swaths. At this map scale, it's difficult to see deforestation in much detail. You'll zoom in and take a closer look, but first you'll bookmark the current map extent. With the bookmark, you can quickly navigate to specific map extents. To do this, on the ArcMap main menu, click Bookmarks, and then in the sub-menu, Create Bookmark. Change the bookmark name to Redania. Now on the Tools toolbar, click the Zoom In tool. When you move the pointer over the map, it becomes a magnifying glass. Now let's draw a rectangle around the area of deforestation in northwest Redania. This map zooms to the extent of the rectangle. Now once zoomed in, you can see the deforestation in more detail. Deforestation is often patchy, very similar to the image. Typically, small strips of forest are deforested through a process called slash and burn agriculture. In slash and burn agriculture, small farmers cut and burn plots of forest to create fields. The burned biomass serves as fertilizer for agriculture on the cleared land. This agriculture technique has been practiced for centuries throughout the world, to include the Amazon. Now, in a small amount, slash and burn agriculture can be sustainable, But when the widespread, massive areas are cleared in a small amount of time, it can create a drastic effect on the ecosystem. Next, we'll compare the deforested area layer to the visible deforestation on the imagery base map. To see both the layer and the base map at the same time, we'll change the transparency features on the deforested area layer. So in the table of contents, we'll double click on the deforested area layer. Now in the layer properties dialog on the display tab, change the transparent setting to 50%. The higher the percentage, the more transparent the layer will be. Then click OK. Now tip, if you have difficulty seeing the base map through the transparent layer, you can also turn the deforested layer on and off to compare. We'll try that now. You can see where visible deforestation overlaps with areas in the deforested area layer. However, some parts of the layer do not seem to coincide with deforestation visible on the base map, especially areas close to the untouched rainforest. Deforestation is a constantly changing process, and the base map may have not been updated to show its recent occurrences. Now, another noticeable pattern is that the deforestation sometimes ends abruptly with fairly sharp boundaries. Now, we can see that specifically in this area here. Let me change the cursor. In this area here, it has very abrupt boundaries. Now, these boundaries are defined by protected areas, which either prohibit or greatly restrict deforestation. Protected areas come in two types: protected forests and indigenous territory. Feature classes for both the Brazil training Geodatabase. Now you are welcome to add them both to explore, but for this project, you'll only need the data on protected forests. Now, open the ArcMap main menu and go to the Bookmarks tab and click on Redonia. Now what you can see is this takes us back to that extent that we initially bookmarked moments ago. Then, in the catalog window, click Add Data, add the Protected Forests layer, named Redonia Protected Forests, add it to the table of contents, then move it below the roads layer, but on top of the deforested area. Now what you'll see is that the protected forest layer covers the layers under it. Now you'll change the symbology to make it transparent. So in the table of contents, we'll double click on the symbol and change it to pink. Now instead of changing it in the right hand side, what we'll do is we'll go to one of the preset options as we're searching for pink and select that. Then click OK. Then we'll open the layers properties under display, which should still be set based off of changing it for the deforested areas, and we'll set that transparency to 60% and click OK. Now the protected areas seem to be an effective deterrent against deforestation. Now that you can see one of the preventative measures against deforestation, you'll investigate its causes. Now in the previous lesson, you turned off the roads layer because of the dense road network obscuring other layers on your map. Now, you'll take a closer look at those roads and see how they relate to deforestation. So back in your table of contents, let's take a look. So right now we have official roads and Redonia roads. Well, let's just change this to roads in the table of contents. So you can do that by clicking and then changing the layer and pressing enter. So now on the roads layer, let's turn that on. And let's zoom the camera by clicking our zoom in button. Let's go back to the northwest corner of the state. Now pan and zoom around the map, paying attention to the distribution of roads and deforestation. You can see that there's a strong relationship between roads and deforestation. In fact, 95% of deforestation in the Amazon rainforest occurs within 5.5 kilometers or 5,500 meters of a road. Roads allow access to the otherwise impenetrable rainforest and facilitate the transportation of lumber and logging activities. Now, unlike official roads, which connect cities, unofficial roads access deeper areas of the rainforest and connect rural properties. Now, our goal for this training session is to estimate how much deforestation will occur on a proposed road if its construction were allowed. Now, to make this estimate, you'll first find how much deforestation is associated with existing roads. So let's return to the Rhodonia bookmark by selecting Bookmark, Rhodonia. Now we'll select a sample area to analyze. But before we begin our analysis, you'll select a sample of the existing road networks. The road network is massive with over 20,000 features, 26,664 to be exact. Now performing analysis on the entire thing would take a lot of time. However, selecting a sample area may affect our results slightly, but it'll improve our response time and overall should give us a good sample of the overall trends exhibited inside the state's entire road network. In the table of contents, let's turn off all of the layers except roads and the imagery layer. Now a tip, you can do this by right-clicking on layers and then turning all layers off. This is particularly useful if you have a multitude of layers like we do, or more. And then let's turn on roads, as well as our imagery base map, our Brazil colorized terrain. Now to select a sample of the roads layer, you'll use the Select tool. The Select tool selects features from all selectable layers. Turning off the other layers makes them unable to be selected, ensuring that only the features in the road layers will be selected. Now the base map has no features, so it has nothing to select. And when we select, it'll just be selecting from the roads layer. On the tools toolbar, select the Select Features tool. Note, if you click the arrow next to the Select Features tool, you can choose from several selection methods. Clicking Select Features tool will use the Select by Rectangle method by default. But there are other options. But for now, we'll select the default selection, Select by Rectangle. Now, we'll draw a map around the northwest portion of the state. Now, your selection doesn't have to match the demonstration exactly, as our results will be a little bit different, but generally within a few percentage points. Now, the features within the box are selected in the map. Some roads that extend outside in the selection area are selected. Now, if a part of a feature is in the selection area, then the entire feature is selected. Now, in the ArcMap main menu, click Selection, then choose the Zoom to Selected Features option. And this will focus our map on that selection. Now the map zooms to the extent of the selection. Some of the selected roads, particularly in the northern end of your selection, are not near visible deforestation. You can turn on and off the deforested area layer to confirm. Other roads are inside very dense deforestation. Overall, your selection gives a general representation of the roads in this area. Next, we'll find deforestation near our existing roads. This will begin our analysis. To estimate the impact of the proposed road, we'll first determine the impact of existing roads. You'll measure this impact by the percentage of area around the roads that is deforested. To find this percentage, you'll create a buffer around your road selection, then compare the buffer's area to the area of deforestation inside the buffer. On the ArcMap main menu, click Geoprocessing. The Geoprocessing menu expands. This menu contains 6 of the most commonly used geoprocessing tools, as well as options to find and use tools. Geoprocessing tools are operations that manipulate geographic data. Typically, they take an existing data set as their input and run a process to transform it into a new output. In the Geoprocessing menu, click Buffer. The Buffer dialog box opens. In this dialog box, you'll set your input dataset and a few parameters needed to run the tool. One of those parameters sets the distance of your buffer, or how far away from the input features the buffer area will extend. We already know that 95% of deforestation in the Amazon occurs within 5.5 kilometers of roads. So this is a good distance to set for your buffer, as relatively little deforestation occurs beyond this distance. Now, a tip, for an explanation of either the tool or a parameter in the tool, you can click the Show Help at the bottom right-hand corner of the tool window. And this will provide an explanation of each of the options in this pop-up or in this tool, as well as an example input for each. Now, in the buffer dialog, for input features, we'll choose roads, or Redonia roads, if you have not renamed it. Now, when you choose a layer as your input features, only the selected features are used as the input. If no features are selected, all features are used. Now, if you want to use a layer that is not in your table of contents as your input, you can use the Browse button and browse for location and data. That is the file folder listed on the right-hand side of this input box. Now, for output feature class, we want to confirm that the output location is our Brazil training geodatabase, the Brazil Geodatabase. The name of the output feature class is at the end of the text string. In this instance, it's Redonia Roads Buffer 1. However, for yours, it may just be Redonia Roads Buffer. Now, this is the second time I'm running through this training data, therefore it appended a number 1 at the end of the text string. Now, you can change the name to whatever you want, but the default for our training case is fine. For distance, we'll select linear unit, and then mine defaults to meters. However, as you can see, you have a wealth of options, both in imperial and metric, to select from. But for us, meters is fine. Now, again, 95% of deforestation occurs within 5.5 kilometers of roads. So for this, we'll put 5,500 meters. Now, you could also, though, under the drop-down, select kilometers, in which case we would do 5.5 kilometers. Either meters or kilometers is fine for this. However, make sure you get your decimal point correct, either 5.5 kilometers or 5,500 meters. For dissolved, we'll leave the the default options for side type, end type, and method as the default. However, for dissolved type, we want to select all. So this will create one feature. At the bottom of the buffer dialog box, we will now click OK, and this will run the tool. When you click OK, the buffer tool runs. Now, when the process finishes, which may be of varying time lengths based off of your system performance, the final result layer is added to the map. In mine it is pink, but again, your symbology may vary. Now when the output of a geoprocessing tool is added to the map, you'll find how much deforestation, or whether we are now able to find how much deforestation falls within this buffer zone. Now to do this, we'll go back to the table of contents and add, or rather drag the Redonia Roads Buffer 1, or just buffer layer, under the deforested area layer, and then turn it on. If you have a hard time viewing the layer, as I do, you can go ahead and clear the selected features, which will clear the selected roads that we have highlighted. This is fine as we now have our set and we don't need to continue using these. So again, we're having a hard time viewing the deforested area, so we can turn on and off the roads. Now we begin to see, but it's still rather difficult to view the buffer area with the deforested area. So let's change the symbology to something a little darker to make it pop a little bit better. For me, I'm going to choose it to a gray at 70%, which now we can see that there's quite a disparity inside of that roads buffer with the deforested area. Now, as we continue to compare, we realize that a significant portion of the buffer overlaps with that deforested area layer, although not necessarily in a uniform manner. Now, the northwestern part of the buffer has many areas that are near roads, but have relatively little deforestation. To calculate the percentage of the buffer that is deforested, you'll need a layer of deforestation within the buffer. Now, once again, we're going to use a geoprocessing tool. This time, we're going to use the geoprocessing tool called clip. What clip does, the clip tool, clips the extent of one layer to the extent of another. So to do this, we'll go back to the ArcMap main menu. Once again, click geoprocessing, then clip. This opens the clip dialog box. Now this one consists of input features, clip features, and output feature class, as well as an optional XY tolerance. Again, we have the ability to click the show help button, which will give us a description and examples of each input field. Now, for input features, we're going to choose, the Redonia deforested area layer. For the clip features, we're going to choose the buffer we just created, the Redonia Roads buffer, and in my case, it's buffer 1. Now for our output feature class, we want to name it to something that we'll be able to recognize quickly. So mine shows up with Redonia _ deforested _ area and then _ CLI. Well, that's not as clear as we would want it to be. So let's change that last one to CLIP, or spelling out the full name clip. Now we're going to leave the XY tolerance off, which is an optional feature. Oh, as you can see, I received an error. Now this error occurred because I already have something in my training database called Redonia deforested area clip. So what I'm going to do is I'm going to append a number 1, which will clear the errors inside of my output feature class. Now we can run this geoprocessing tool. But as we resume, when the tool finishes, the clip layer is added to the map. Now, we'll be able to calculate the percentage of the deforested area near the roads based off of our clip. So we've created 2 layers. One shows the area within 5.5 kilometers, or 5,500 meters, of the roads within our sample area. And then the other shows the deforestation within that buffer. Our next goal is to calculate the percentage of the buffer that is deforested. Now, to find that percentage, we'll calculate a new attribute field. So to do this, in the table of contents, we'll right-click our newly created layer, Rhodonia Deforested Area Clip, or Clip 1 in my case, and choose Open Attribute Table. Now this layer has two fields. These are fields of geometry that are automatically created for all polygon feature classes. And they include shape length, basically the perimeter of the feature, and the shape area. Now, let's examine the shape area field. Note, because the area is based on the sample roads we selected, your area values that are present on your screen and all subsequent values you calculate from will probably differ from the example in images. Again, this is based off that selection we initially did and will vary depending on which features were included in your selection. Again, the number may be different, and that is fine. Now, the unit of measurement is not given in the table, but specified in the layer's coordinate system information, which we will check momentarily. Now, we can leave the attribute data table open and open the Rhodonia Deforested Area Clip layer. We're looking for the layer properties box, and we can do that by double-clicking on the layer. And then we can see that the layer properties opens up. Now, as usual, it defaults to the last box, or rather the last tab that we operated in. But what we need to do is move to the Source tab, and then under Data Source, scroll down to the projection information. Now, the projection of the data is South America Albers equal area. Output layers made from geoprocessing tools use the same projection as their input. Below the projection name is the technical information about the projection, including its linear unit, which is the unit of measurement used by the projection. For South America Albers projection, the linear unit is the meter, which we can see located here. Thus, the shape area in the field in the attribute table for the clip is square meters. Now we can close the layer properties box, dialog box, and return back to our attribute table. Right-click in the shape area value and choose copy. Now, of note, what you may want to do is in your programs, open a notepad to have a place to store these values. So we'll do clip shape area, and then we'll paste it into there. Now, in the table of contents, we want to right-click the Rhodonia roads buffer layer, which mine is Rhodonia roads buffer 1, and open the attribute table. You'll see that this opens it in a separate tab at the bottom inside of our attribute table box, dialog box. Now, like the deforested area clip, the roads buffer layer has a shape area attribute. Now, what we're going to do, though, is add a new field to use both area values and find the percentage. Now, to do this, on the table's toolbar, which is located in the upper left, we'll select the arrow drop-down and Add Field. In the Add Field dialog box for name, we want to type %deforested. Now, if I tried to use this value, it would throw an error because spaces are an invalid character for the name field. So we'll go back and add an underscore. For type, you can see we have many options, but for this, we'll want to choose double. Now, for the alias, we can go ahead and copy the %deforested. Now, unlike the name field, we can have a space, and we'll add it in lieu of that underscore. Once we're done, we can go ahead and click OK, and the added field will show up on our Redonia Roads buffer attribute table. Once it is added, it has a null as its value. Null is the default value for new fields and is equivalent to having no value. Now, to add a value, you can edit a table cell directly, similar to how you would in Excel, or create an equation to calculate values, which is what we will do. To do this, right-click on the % deforested field and choose Field Calculator. Now, a warning will pop up that explains that you're about to calculate a field outside of an edit session. This is okay. Go ahead and click Yes. The Field Calculator opens. Now, the Field Calculator is very similar to our Select by Attribute dialog box in that it prompts you to build an expression. This gives you the standard mathematical operators and functions, as well as existing fields in the attribute table to help build your expression. To find the percentage, you'll divide by the area of the Redonia deforested area clip layer by the area of the Redonia Roads buffer layer, and then multiply the end result by 100. So to do this, in the Field Calculator, in the text box at the bottom of the window, paste the area value that you copied from the Redonia deforested area clip attribute table. So to do this, it may still be stored on your clipboard, but to make sure we get the right response, we'll open back up our notepad, copy that value, and paste it in our expression box builder. Now, in the list of mathematical operators located here, we'll want to choose the division button. Under the fields located here, double-click the shape area. Now, what this will do is this will give us a ratio, but not necessarily a percentage. So to do that, we'll bracket off this initial ratio and multiply it by 100. And this will give us our percentage. Now, again, I want to iterate that your number, specifically this number here, will likely be different than mine. And when we click OK, it'll calculate, and this % deforested will likely be different as well. However, it shouldn't be significant, maybe a delta of plus or minus 10%. Now, you now know that the percentage of land within 5.5 kilometers or 5,500 meters of roads that is deforested. If a new road were built in this sample area, you could predict that a similar percentage, in my case, 36.5% of land within 5.5 kilometers of that road would become deforested. Now that we have this value, the deforested area clip layer is no longer necessary. You'll remove it from your map. You'll keep the roads buffer layer because it has the percentage value in its attributes, but you can now turn the layer off as well. So we'll go ahead and close out of this attribute layer. And in the table of contents, we'll turn off the Redonia Roads buffer, and we'll also collapse it. And then we'll right-click on the clip layer, the Redonia deforested area clip, and select Remove. Now, this layer is removed from our map document. However, the feature class still exists in our Brazil training geodatabase. Now what we want to do is return to our Redonia map extent by clicking on Bookmarks, then Redonia, and then because of the significant progress we're made, we'll go ahead and save the map. So at this point in time, we've looked at deforestation in Redonia and determined its relationship to the roads. Ultimately, we determined the percentage of lands around the roads that are deforested. In my example, that was a little over 36%. Now next, or rather in the next training block, we'll apply that percentage to the proposed road to estimate how much deforestation was prevented by the road's prohibition. So this concludes our second block of training, and I look forward to seeing you in our third block.